This demonstration presents an interface between Capella and Safety Architect. It is developed in the context of the French Clarity project. Safety Architect is a safety analysis tool based on system functional or architectural models. Indeed, Safety Architect can import design models from user modeling tools such as System Architect, Rhapsody, Skate System, Papyrus, or Capella tool in order to perform classical safety analysis, namely local failure condition analysis that we call local analysis and automatic generation of fault tree, or for the identified failure event that we call global analysis. Then, different reports such as FMA tables can be generated, and the fault tree generated in Safety Architect can be exported to other fault tree analysis tools like Fault Tree Plus or App Analysis for probability computation. Safety Architect is an Eclipse-based tool built to be simple for users. For example, users can import models from different modeling tools by using the classical file import menu. In this video, we focus on the interface between Capella and Safety Architect. This interface is composed by three features. The first is the safety viewpoint that annotates the Capella model by failure events. The second feature is the export-import facility from Capella to Safety Architect. And the last feature is the feedback of safety analysis from Safety Architect to Capella. Let's illustrate these features by using the Capella sample model, the EF example, which is the Capella sample model of in-flight entertainment system. Thanks to the safety viewpoint in Capella, user can associate failure events to the output of a system or subsystems. For example, here we associate a failure event by drag and dropping the failure element in the palette to the output port of the function send audio stream to aircraft cabin speakers. This association is not only graphical association, the semantic of this association is shown in the semantic browser view. Then, one of the classical failure modes, for example erroneous, is associated to the failure event in order to specify how the relative output port, here the audio stream, fails. The export-import feature is a connector from Capella to Safety Architect. There are two ways to export and import from Capella into Safety Architect. First, thanks to the classical file export and import menu, the user can select the whole architecture or just some functions to export them into Safety Architect for safety analysis. The second way is the use of the contextual menu. The user can just right-click on an elementary function in Capella and import in Safety Architect all the graph of function and functional exchanges related to this function. There are three options for this contextual menu. The export to a new Safety Architect project action creates in background a new safety architect project from the Capella project, and open directly the safety viewpoint of this function in Safety Architect for local analysis. The safety viewpoint of function in Safety Architect is the annotation of input and output ports by failure modes. We can see that the failure event added in Capella is also imported in Safety Architect, and it is associated to the related failure mode, here the erroneous mode. We open a relevant local analysis diagram action, open a safety viewpoint of this function already existing in Safety Architect for local analysis. The local analysis is realized thanks to the logical gate and propagation links that link the failure modes of input ports to the failure modes of the output ports. The last feature is the feedback of the safety analysis into Capella. The connector from Safety Architect to Capella returns the fault trees generated in Safety Architect as critical functional chains into Capella. A critical functional chain represents a set of functions and functional exchanges involved in the apparition of a failure event. By right-clicking to a failure event in Capella and by clicking to a Run Global Safety Analysis action, the critical functional chains are computed from the related fault tree generated in Safety Architect. Then, the critical functional chain can be displayed in the Capella diagram. The logical operators of fault tree, such as AND gate, are represented as AND constraints in functional chain involvement in Capella. To resume, this demonstration presents the workflow between Capella and Safety Architect to facilitate the co-engineering between system engineers and safety engineers. One of the benefits of the feedback of safety analysis into Capella is to highlight the critical functional chains that can lead to the failure event already identified. We hope that this can help engineers to explore alternative system architecture in this perspective to facilitate the safety demonstration. Thanks for your attention.